processing sector. Mr. Shaktipal is on several advisory committees, including the World Cashew Convention, and has, after a long and illustrious career at TechnoServe, moved on to join Caronut. The other panelists, we have requested the other panelists to join us here. Ms. Cashew, Head of Customer Experience, Sapmarine. Mr. James Oborowski, Country Director, TechnoServe Benin. Mr. Jayachandra Reddy, Technical Head, Wind Corporation, DMCC. And Mr. Charlie from the Mayor Corporation. Thank you so much for joining us here. Ms. Kishore Siddiqui has been using technology tools to enhance customer service experience at Sapmarine. She will share with us how technology can empower customers with tools and techniques to monitor, control, and manage operations effectively and control risks. Mr. James is the Cashew Director, Benin of TechnoServe, and has been working on improving the viability of cashew processing in Africa. TechnoServe has been working on power generation from cashew shells and has built a business case for the same. Mr. James would share more details in this regard with us. Mr. Jayachandra Reddy is perhaps one of the few technical experts who has worked in India, Vietnam, and Africa, and has a lot to share on mechanization and automation. He would share his experiences with us in greater details later. X-ray technology use in cashews is relatively a new trend. Mayor is the front runner in this area, and Mr. Charlie would give us a glimpse of technology and the need for the same in cashew processing industry. And with that, of course, I hand it over to take control of the next session with Mr. Shaktipal welcoming you and the experts. Thank you.
Let's talk a bit about innovative solutions and technologies, how this can help market, and how having right solutions in place, how right technologies in place can ease the doing of business and ease of lives. In this session, we are going to talk a bit about cashew processing globally and the ways innovations or technologies can support to bring the cost down and support the food safety in place. We also talk about how to enhance competitivity, especially on those origins which are not actually taking use of all the byproducts, which is an essential part of processing. We also talk about a bit on how the world is changing. A shipper, a supply chain partner who talk all the time about shipping, coming up with so many other things, which is very much focused on the customers-based solutions. We'll hear a little bit about what's next into that sphere, how that they can come up with new solutions and provide a lot of things which are not there, actually. And at last, some emerging needs of the industry to address food safety in place, how X-ray solutions actually can support this new revolution. I'm going to talk, I will start with Ms. Kishore Siddiqui. She is the head of delivery, Middle East, and her logo is all the time customer-based solution. And she always she's very passionate about how with whatever should be in place, we can actually enhance the experience of a customer. And I think that's what more or less her all efforts are. And she's going to talk a bit about enhancing customer experience by use of new technologies and tools. And let's see how these tools are going to help us and make us better and give us a better environment to compete with. I would like to invite Ms. Cashew Siddiqui. Please give her a big applause. Thank you.
Okay, thank you, Mr. Shakti, and a very good morning to all of you. I think first, if we have the presentation.
At Maersk, we move 20% of the world's trade. Now, imagine making that experience even easier for our customers by connecting and simplifying their supply chains from end to end. Ready, set, go. We're surging ahead as a united front to build a seamless customer offering that can flex and scale to meet every need. It will extend the industry's largest and most reliable delivery network to all markets across the globe. From point A to point B and every moment in between, we build on our strength in shipping, ports, and logistics, simplifying, connecting, and transforming the industry. Digital technologies allow us to easily engage customers and enhance our overall experience, keeping everyone in the know every step of the way. We are in the lead and prepared for the future of container logistics. By uniting the best innovations from sea to land, we will excel on every surface. With that strong foundation and digital lead, we are the world's integrator of container logistics, allowing our customers greater access to global trade and growth. With our dedication to constant care and teamwork, we can elevate our offerings and deliver consistent results. No matter the obstacles we face, we remain strong and agile. We are one Maersk, united for growth.
As the world's largest container shipping company, we move 12 million containers every year. That's almost 20% of the market share of global trade to every corner of the world. The vision of Maersk is to simplify and connect global trade. We focus on simplifying container solutions from end to end, taking out the complexities of the shipping cycle and making our customers' life much simpler and easy to operate in a complex shipping world. So our vision is to be the global integrator of container logistics, connecting and simplifying our customers' supply chain. How do I move to the next slide? Until December last year, Maersk's main focus was in the ocean side of the business, and from January onwards, we have ensured that we have integrated the logistics expertise that we had with our Damco services, and we will ensure that we have an end-to-end solutions for our customers, which means from the farm to your refrigerator or from the factory to your wardrobe. We have an inbuilt solution for all the customer requirements. So whether it is logistics or trucking requirement for us shippers' requirements at the origin, or whether it's the customs clearance, warehousing and distribution, or building a value-based service is something that we would be focusing on with Maersk, with our pioneering, innovative, and digital solutions that we have built for our customers. Technology is becoming more and more important than over the last few years. At Maersk, we have a very, very well integrated business and technology team that speaks to each other to understand customers' needs. And we do appreciate that our customers are on the move. Traders, like most of you in this room, time is of immense value. And having applications and solutions that allow you to be on the move really helps us understand your needs, and that is why we are spending most of our technology time to ensure that we give you products that takes away the complexities of the cumbersome and the delayed processes sometimes that the shipping has to go through, and offer you digital products. We have the Valley Protect, which is a very, very new product that Maersk will be offering to all its shipping customers, which is an insurance, which is going to be as simple as clicking a button at the time when you're making a booking. We also have solutions such as trade finance, which I will be speaking a little more about in my coming slides. We have the blockchain solution, TradeLens. We've got 4PL, container logistics, supply chain management. So there is a huge gamut of products that we have with inbuilt digital solution. The Maersk technology team has spent many years to make sure that we have a successful digital platform that gives you self-service instant booking, which means you have a booking confirmation immediately throughout your booking journey. So that was a glimpse of the instant booking solution that we have inbuilt for our customers. There is another product that I very proudly present, which is the Maersk Trade Finance, that actually helps our customers to get into very easy finance solutions. We all know that financing can be extremely tiresome, having several meetings with the bank, a lot of complicated paperwork solutions that we have to offer. With Trade Finance, we have a solution that is paperless, and in fact, since the time you meet our trade finance expert, until the time finance is dispersed, there is no paperwork involved.
Trade finance made simple. If you ship containers, you'll know that financing and shipping can be cumbersome. Due to heavy paperwork and incompatible systems, trade finance takes a lot of effort and time. This causes a lot of waste for your company. Worldwide, it sums up to a lot. So we understand that you're tired of wasting time, trees, and business opportunities. That's why we've decided to merge trading and finance and combine it to provide a single window for the flow of goods and money. By doing this, we're offering you fast access to capital, fast and simple processes, reliable transport, and access to a global market. We are able to finance both pre- and post-shipment operations so that you can focus on expanding your market share globally. We call it Trade Finance Made Simple.
We have an expert team of trade finance specialists amongst us in this room, which you all can get in touch with during the day to get more information on trade finance. Another initiative, which is a major leap that Maersk has taken along with a joint venture with IBM, is a blockchain solution called TradeLens. It is an open and neutral platform that is digitizing the global supply solutions and transforming trades. With more than 90% of the cashews originating from Africa, we are proud to say that Africa is one of our focus trade areas as Maersk. After more than a century of doing business in Africa, and with operations across all countries within the continent, we can truly say we know Africa. With our extensive network, with our presence and local knowledge, we are always looking for opportunities to have infrastructures and logistics connections to accommodate economic growth. I'm leaving you with this last slide, which is more about what it means as customers to get connected and do business in Africa.
Thank you very much, Kishwar. I think everything's clear. The last slide when we say Africa, at the same time we talk about trade financing, how we can actually take the opportunity of this type of new innovative solutions in addressing the industry's trouble, which is very, very occurring in nature, which is liquidity problem which cashew industry is facing. Thank you very much, Kishwar. We will take all the questions once we finish all the presentations. I would like to invite now Mr. James Oberwowski. James is going to talk about improving competitive position of cashew processing in Africa through power generation. Africa is emerging in nature. Many countries already start processing. They face day-to-day difficulties. It is not that they are not competitive on the cost side, but many of the other factors which are not supporting them, and one of the major factors is what they are going to do with the cashew shells, which are not producing any revenue, but at the same time is a big cause of the environmental damage. How we address these things properly. Some origins took initiative coming up and processing cashew shells into CNSL, but still the business viability is not there. How we see a further step ahead, and that's how a continent which is energy deficient can take the use of this biomass, converting that into electricity, and that's what James is going to talk about. James is actually, he's the acting country director for Technosoft Benin program, and but he had a lot of experience in addressing the value chains and value chain efficiencies, starting from one of his major goal is to how to support farmers, industries, and public sector partners with technical support to expand the industry in wherever origins he actually worked with. He has quite more than 12 years of experience in emerging markets, has convinced him that business opportunities combined with the right support can deliver prosperity to farmers, entrepreneurs, and communities. He has also advised and co-founded several agriculture-oriented startups, and from last 2010 till 2014, he led various public-private partnerships in Haiti, and also had a rich experience working with corporates like Coca-Cola, and Technos is very delighted to have him and to create that big impact in Benin. So give him a big hand to talk about his experience, how this project is going on.
Good morning, everyone. Thank you for being here. I'm very happy that Ms. Siddiqui had led off or finished off with this slide about Africa, talking about transport infrastructure. I think we're hitting a nice theme now about core infrastructure on the continent, about which I'm a tremendous optimist. So to give you a bit of context, energy on the African continent. ECOWAS nations have about a 16% access to energy rate. This is due to both transmission capabilities and generation capabilities. And even within the continent, we see very big differences. So, for example, South Africa leading with a very high connection rate. We can see that actually for many countries, this rate is very low, even in the single digits in some cases. So how do we close that gap? 16% is incredibly low for access to electricity. We expect that the demand on top of that will actually increase by at least double. Some estimates put it triple the current demand for electricity across the continent by 2030. And by 2040, we expect that actually renewables may account for 40 to 60% of supply. Hydropower is a major element of that. There are some investments in gas, but solar is also becoming increasingly attractive. Why renewables? It's also because, with the exception of a few countries like Nigeria, most countries in Africa are importing their hydrocarbons or their electricity. They can't afford it. And one of the great advantages of renewable energy is that the cost per kilowatt is much, much lower than they're currently experiencing. So what does this have to do with cashew? Cashew shell is actually currently primarily burned in open pits today, where we have processors, because there is not an off-taking market in most African countries. And the open burning is a tremendous environmental hazard, as it's creating toxic fumes and gas for the communities around it. It's also a waste of a tremendous resource which is generating value in other processing countries, particularly in Asia. So we have an opportunity. The de-oiled cashew shell has a similar energy content to lignite coal. It's very high energy content that makes it a fantastic fuel if we have the technology to use it. And other countries have already done this. We're not inventing something. In India, there's various plants generating between 1 and 6 megawatts with cashew shell energy. So why not Africa? So we're going to show a case study in Benin of the project that we're developing in partner with Fludor, who I have an esteemed colleague on the panel with us, about a joint project we're working on to show the way for Africa and how cashew shell can be turned into a very affordable, reliable energy source and help reduce that energy gap that we saw. So Benin is a particular case, as we looked in the first slide for the overall deficiency. Only 11% of Benin's electricity is generated within the country. Everything else is imported from neighboring countries. And this presents a huge challenge for the country, for their balance of payments, for the affordability of electricity. It's one of the most expensive countries in the world per kilowatt. And looking forward to where we want to fill the gap, there's still a tremendous gap within the country between urban and rural areas and between the expected demand and what we can currently provide. The government of Benin has very ambitious targets to be able to increase the per capita consumption, reflecting increased productivity, reflecting economic growth, increased wealth of families, changing lifestyles. Their master plan expects 6 to 9% increase. And the government of Benin is committed to meeting 70% of their needs, so 11% to 70% by 2025. It's a very ambitious goal. So our program, Benin Cashew, saw cashew shell as an opportunity to help meet that gap. We worked for the past year. Those of you who were in WCC a year ago remember our preliminary feasibility study. So you spent the past year designing the right mix of technologies, identifying proven solutions, putting together the technical team necessary to make this a reality. With Fludor, we identified a power generation plant of 1.5 megawatts. Why 1.5 megawatts? There's a combination of on-site needs, minimum scale for efficiency, and the feasibility and the availability of the equipment and technology currently available. Based on our business analysis, a 1.5 megawatt plant will have a net margin of 15% and will generate a break-even within 3 years. There aren't a lot of infrastructure investments you can make in West Africa and have a return within 3 years. So it's a very attractive use of capital, a very attractive investment. You can see when I talk about scale, we see power generation through turbines using cashew shell over 1 megawatt. Almost all have a positive return. Below 1 megawatt, we see that the initial investment, the technical cost, and certainly the maintenance cost over the time minimal staff required to operate a turbine, makes it unprofitable with current technology, although this may change as technology evolves. So after looking at this model in Benin, which we're hoping to break ground on shortly, we wanted to take a look at the wider context. Is this something that can be done elsewhere, or is Benin a one-off case with our particular environment, energy costs, etc.? So across the continent, cashew production stands at around almost 2,000 metric tons, growing on average of 7% per year. Processing volumes are around 160,000, which seems small compared to Vietnam and India, but it's growing, and we see an increased dedication of countries across Africa to support their processing industry and to move more processing and value added closer to areas of production. If we were to process all production locally, we would be able to generate up to 105 megawatts of electricity across the continent, generating thousands of jobs, tens of millions of dollars in revenue, and reducing carbon impact by up to $8 million, or about 600,000 metric tons. Because we're replacing generally hydrocarbons for production, whether it's diesel generators, whether it's gas-powered turbines in the grid. So looking at analysis across different countries, their cost basis, labor, land, investment costs at different scales, we've actually found that in most cases, power plants can be profitable. In some inland countries that are particularly energy deficient, even a 1 megawatt plant would have a positive return. From 1.5 megawatts, we see that in many different scenarios, the returns are quite attractive. Thank you very much.
Thank you very much, James. When we talk about power generation and how it's going to impact the competitive processing in Africa, I would like to tell you one more thing, that if we adopt such models in Africa, that is going to add around $55 additional to the profitability of a processor when he processes 1 metric ton. That's actually is the whole profit which he can think to gain these days. So you see how such type of initiative can totally change the dynamics in African processing. Thank you very much. I'm going to now invite Mr. JC Reddy. I think he's always ready actually to do something innovative. That's what his DNA is actually. I had a chance, I'm very privileged to be with him many places. He's a man of always mechanization, automation, efficiencies, product quality. So he's always in his own sphere, always talk about how best he can design a machine linked with a right technique, bring right sort of balanced automation, and address the problem properly within that context. So he's a man of passion. I would like to invite him to share his experience, to tell about what are the different prerequisites to adopt a technology. Is this enough to adopt a technology? Then what sort of automation can help to really address your objective of reduction of the cost side? So he's going to share his passion. Please give a big hand to Mr. JC Reddy.
Good morning to all delegates and participants of WCC 2019. Yes, just this session we are much emphasizing on the difference between the mechanization and automation, which is oftenly get confused, by the people. Someone says that it is a mechanical plant, someone says it's a semi-automated plant, someone used to define it as automated plant. It's a minute differences between the process, and a lot of evaluations happening for last 5 years. You might have seen particularly last 5 to 7 years. In fact, industry was well equipped and decently established themselves as a reasonably mechanical setup. Now today is a time that what is the next phase of activities in the mechanization? That's what we are just touching upon, called automation. Okay. So just index of this particular presentation, which is a very short presentation on mechanization versus automation, what exactly it means. The why automation, is it required, is it timing, is it perfect time to go for an automation, whether you are matured enough to handle that kind of automation. And what is the prerequisites? This is one of the very critical factor. People say that no, before going to any such kind of mechanization, where we stand, whether we have a capabilities or skill assessment or skill management to handle that kind of automation. There should be some always fundamentals which last 20, 30 years of a lot of experts from the manual process, mechanized process, we learned so many things. We burned fingers so many times. So these all, there may be a lot of case studies of each and every issues where these fundamentals can be applicable for the automation process. And most importantly, and how to design a plant with these fundamentals, what we have learned in our life for last 7 or 8 years of mechanization. And most importantly, what's the fundamentals on the good manufacturing practices, which strengthens your automation process. Otherwise, without GMP and going for automation is really unwarranted. If you look into a simple concept, how to differentiate between the mechanization and automations, which is very visible in cashew processing. A mechanization, you can say that, which saves the use of a human muscle. And mechanization displaces a physical labor. Or you can say that a replacement of unskilled and semi-skilled human power. This is what exactly happened last 12 years of mechanization. So you've seen that a lot of shelling activities, peeling activities, and grading activities, a lot of things started slowly, mechanisms where you have replacing only a physical labor, like shelling and peeling machines, graders, sorters, sizers. And if you look into an automation saves the use of a human judgment. The human judgment and human muscle is a small difference. And just peeling, or you can say continuously scooping, is a normal human work, muscle work. Whereas identifying the right temperature, identifying the right humidity, identifying the right conditions for the processing in different sects, is it right time to cut, right size to cut, or maybe which is the best machine to suit for this? These are the one area where we can consider as an automation concept. And this will displaces the mental labor as well as replaces the skilled and supervisory sector. Whereas if you differentiate between the mechanical and the mechanical saved almost a considerable cost, whereas automation strengthens your system and it can expose it to the global standards. For example, auto thermal controls, auto moisture controls, auto humidity controls, and auto filling or stacking or feeding activities, and auto positioning of RCN and kernel and auto rework. These are the basic fundamentals we have identified, or we can say that we are in position to assess the next future way forward. If you look into the automation, we strongly suggest that it minimizes the workforce, even it should be less than 1 worker per bag. You remember exactly around 7 or 8 years back, we used to operate with 5 to 5.5 workers in India. Particularly Kerala was at the time one of the top performers, and Andhra and all, we used to perform with 5.5 workers. And later from that day, today a lot of factories in India today operating with 1.5 workers, 1.8 workers and 1.4 workers range. It's a tremendous improvement happened in mechanization. Now with automation, one step forward, that taking that mechanization to next phase of activity, we are strongly visualizing that this will happen, that the workers per bag should be less than 1. Some factories in Vietnam are able to touch upon, and of course their process and Indian process are quite a difference. No need to always compare both. It have 2 different sectors and 2 different markets altogether. Let's now mix up with those concepts. Let's take separately what exactly happens in India. And most importantly, the raw material to finished goods conversion, it was almost for 14 days in 12 years back, and it's come to 9 days. And to Mangalore factories are even touching today in 5 days or 6 days, and some African factories are touching very 9 days. And we are strongly expecting that automation helps you to bring down less than 3 days. From raw material to before even fumigation, it should complete it within 3 days of a process. That's what automation should help. And mostly a consistency in process quality. There may be different moisture, different issues, different origins you people are processing. There may be always challenges, and this can maintain a consistency. And most less human intervention and microbes. More and more human intervention in cashew. It is already bound to go for a microbiological issues like salmonella, a lot of other challenges we are keep facing. Since food safety and food activities are keep rising and bar is keep rising in Western countries, we should be better to reduce the human intervention. And minimize the infestation risk. More 14 days or 15 days, raw materials are work in process is lying around the factory. You are exposed to more infestation risk. This will reduce in the automation. And there should not be any jute bags, there should not be any gunny bags in the entire system of a processing. This is what we'll call as a jute bag free process. There's a new automation happening now, already started. And attempts towards the crates free factory. Can you imagine that a cashew factory operating without any crates? There should not be any plastic crate in entire factory. It may be a bit difficult to even digest that. Is it possible? Yes, I strongly think and suggest that it's possible. That's what we are thinking, that the next way of automation going to happen is that there should not be any plastic crates in the factory. This completely a silo mechanism system can be incorporated and replacing the different grades. We have a multiple grades, like some companies will do 25 grades, 37 grades, some companies do even 12 grades. So there may be silo mechanism, can aligning these mechanization can go ahead in future. And most importantly, no cashew process to touch the ground. In fact, I remember in Andhra Pradesh earlier days, we used to do shelling, peeling, grading, everything on the ground. People used to sit on the ground. And we don't know what's called tables and chairs. And today we are talking about a different concept. And cashew or kernel, raw cashew nut should not touch the ground. It should be above the ground. The process has to start above the ground. It has to end above the ground. So this is a new model people already started incorporating. I hope you can still work out on those things. And most importantly, minimize interest on working capital, because your total span of process has been come down by almost 75%. And easy maintenance of the good manufacturing practices, and move towards the continuous process from the batch process. Presently, still I have to consider a cashew as a batch process, and to go into the next level of a continuous process, like what are happening in the rice industry. Is one of the highest mechanized industries, the rice. So that is what we call as a continuous process. It should happen in cashew also. It's a matter of time. And what are the prerequisites? What are the fundamental things we have to understand and assess before going to an automation concept? A size and scale of the project is very important. You cannot go for a very 10 bags, 20 bags, 30 bags factory. It is not worth of going for an automation, mechanization. Let's not waste time and money on that concept. Today, the sizable packs to go for an automation should be nothing less than 300 bags per day. That's what I personally visualize that. That's where automation scope. And effective spares management is very fundamental, particularly an automation plant in Africa. It's a big challenge. It's not that easy to think of automation big models in African context, availability of spare parts, availability of services, much of the challenges. And effective spare management, after that, sales service are the two fundamentals. You have to think a strong technical and maintenance skill requirement is very important. So we were the days 25 horsepower of a factory. We are running with 500 people. And today we are running with 450, a lot of companies in India, 450 horsepower of the plant with 200 people. There's a lot of shift happen. So for this thing, the mechanical or skill management or maintenance skill of the every fabricator, manufacturer is very important. You should much from the hard-working labor, you are going to turn towards that engineering-oriented mechanical skill management. Handling of those skills is very different task. Like the way Hindustan Lever handles their engineers is entirely different. The Cashew process will handle their engineers. So this is where the real trend changes. So we have to change our mindset to handle the mechanical skill. And most importantly, multiple parameters for multiple origins. Different origins have a different shell thickness. Different origins have a different skin character. Different origins have a different color. So how to handle these things? So your automation has to handle those things. And most importantly, it is a medium to high investment. You should be mentally ready for that. And aim to maintain a processing cost lowest is very important. Today, some process are talking about $350, and Vietnam process talks about $250, and African process are talking about the $500. That's the way the processing cost. So you should aim that it should be always between the 200 or 250, or even less than 200 in next level of automation. And linear and visual flow is a fundamental for automation. Your flow should be visible. I mean, when you're walking in the plant, every of your activities should be visible to your naked eye. A manual mode is interface. What's manual mode interface means? If you go for too much of automation, if any breakdowns, and it's very difficult, no, you cannot stop the process. That's the very biggest challenge in a continuous process, going from batch. In batch process, any maintenance breakdowns, you not even understand. Peeling stops, still grading continues, shading continues. But when you're switching over to automation, the process becomes a continuous model, like a chocolate company. So any small machine breakdown, entire your line stops. So that is the reason you require a manual interface. Whenever there is a problem, there should be manually, you can overcross that small breakdown time. And low oil contamination, this is one of the biggest challenge today we have in mechanization. So there is a lot of attempts we can make doing that. Oil contamination will come down. This is very important small observation I have seen in my personal experience. So this, I have not written anything on this slide. This is a kernel handling technique. If you see that how the spillways of a hydraulic dams, the dams generally happens that how the water is passing. You are seeing that most of these dams are, spillways are curved system. The water will flow such a way that means it will not have a high impact on the ground and it will not create the dent or it will not create the damage to the civil structure in the water. Similarly, the first, the drawing, what accelerate in the up left is that, sorry. Particularly, you are seeing the first problem in color sorters. Most of the color sorters, you are seeing that a lot of people are putting them crates, plastic crates, to collect the rejects or accepts in the color sorters. You are seeing there's a vertical hit from the machine. The kernel is dropping from 1 meter or 2 meter, directly hitting the plastic, and it may breaks. So next figure, you are seeing that there is a curved chutes are there. This is adopted in the most of the machines in a cut vegetable handling. So a curved chutes are those mechanisms that it will avoid damages to the kernel. It will avoid creation of the pieces, particularly for African processors, more pieces, more problem. So that is, of course, India is a different concept altogether. So these curving systems are the new model you can adopt in every automation methods you are adopting. Because more automation, more silo systems will come, and you have to handle a lot of these systems into picture. The second lowest two drawings are there, like these are two chutes. One chute is an empty chute, and other one is some chute filled with some kernel. Whenever you are filling any silo, filling any chute, this very common thing happens that people will empty out entire chute, they'll try to fill the new material. It's a huge hit, you can see a lot of breakages happen. So keep a deadlock, that means there should be some stock in every silo or anything you handle in your collection bins, that some material should be there in the bottom. It will work as a cushion, or you can work as a shock absorber, that it will not spoil the kernel, not create too much of damages or not pieces generation. This is one of the two fundamentals you can adopt in entire automation, end to end. It's a Cashew nut or kernel, whatever it may be. The next one is very important thing, the kernel positioning at auto scoop sorters or shelling, whatever it may be. What is exactly a kernel positioning means? Today, by nature of the raw cashew nut, it's a structure, it's a gravity impact away from its body. You can see most of the raw cashew nut was standing in one single location and standing in a uniform direction, it's entered into the blades. That's one of the reasons today our cashew mechanization, particularly in the shelling, was very successful, because you are seeing that there is a rails in the system which will position raw cashew nut such a way that means always it will be in one specific direction and enter into the blades. The similar thing, when you're going for your shooters are very common trend today in Vietnam with multiple passes. They passes 3 passes, 7 or 8 passes for auto scooping system. And they keep hitting, in India also same thing happened, a lot of new developments are coming up. So this is one of the biggest mechanization happened that today infinity cycles and uncut was dropped less than even 5%. So that is very specific thing. If you look into this drawing, if particularly the impact of a unscooped shell, if hit in any corner of the shell, it's not a problem. The shelled kernel will come out very easily. Similarly, it hits under the bottom of the shell, also it is very good. But in auto scoop, the decorticators, what you have, hitters, if it hit the kernel side, particularly on the unscooped shelled kernel side, it not only create a piece, and it will create a huge oil contamination. So there should be a position, there should be a technology which a lot of manufacturers are here, can keep adopt it, that even unscooped shell also has to travel in one specific direction without twist and has to hit the wall and it has to come out. This is one new technology. I think a lot of fabricators can take a note of this, can keep adopting that, can work on these models. And most importantly, this is one of the semi-automation concept where RCN cleaning, holding, cooking, transfer, entire system has been synchronized. Like for example, it can be auto cleaned and it is remove the dust. You can install the destoners, it remove the destones, and it can automatically, it can hold in a mega structures, even 60 metric tons, 100 metric tons you can store. That can be directly linked with the cookers, and the cookers take an automatic call and taking material from these things. And the entire material will be automatically dried and transferred to the next segment of your shelling section. This is one of the models successfully has been implemented, is keep working well. The next level of an semi-automation concept, the automatic dryers. The automatic dryers are those dryers which will control the entire moisture. Some RCN may be suitable to cut at 24 hours of drying, some may be at 48 hours of drying. So these you can further go for a mechanical drying system where ventilation system will be entered and air can be passed, either cold air or hot air. So you can bring, and that can be directly linked with your sizers. Up to that, mechanization is very good now. From the sizers, you can say A, B, C, D grades, and that will grades directly go to the uplift silos and directly they link it to the shelling machines. This is one of the first best automation, semi-automation I can say, I cannot say fully automated, a semi-automation happened. If you link this with the humidity and other accepts, then it became a complete automation. That's what the one step, I think it's reasonably successfully one of the best models we have seen, which reduces more than 70%, 60% of the human intervention. And what is called skill management and mechanical automation. I heard most of the process, we say that first 5 to 6 months, most of the mechanical lines is working very well, performance is exceptionally good. But suddenly you can see after 8th month or 9th month, most of the process started complaining that there is a problem in technology, uncut is higher, oil is higher, problems, a lot of new issues. So they suddenly start a conclusion that the technology is bad, the machine is bad. I don't think so. I really not think so. This is not real reason. The skill management to handle a mechanical installation is quite different than a manual processing. This we have to accept it. And we have to encapsulate in our structure in future that we require a lot of mechanical skill today, and we have to respect those mechanical skills to handle the mechanical automation factories. A strong technical team's management efforts are required. We can't handle 450 horsepower mechanical plants in the same way that we handle 24 horsepower a manual process. And preventive, predictive, and creative maintenance are the three fundamental important things. Just you can think forward. That's very must to operate these lines. And they should know that when contamination is happening in a kernel, and one should know within 5 minutes, should assess that it's exactly coming from which phase, whether coming from the shooters, coming from the uncleaned your bench, or it's coming from the lot of conveyors you have. There are so many aspects. So one should assess this contamination issue within 5 minutes and arrest this particular problem instead of trying to do everything. So this skill management is very important. I hope that please take into this as a very serious issue and start recruiting good technical people, very specifically even diplomas or ITAs, whomever you want. But there should be a strong technical skill there. And there's the fundamentals of a plant design, preferably is my last slide. These are some things comes from my experience. I attended so many conferences from the different people. So this is what final observation from a consolidated observation. I personally feel that useful to in mechanization automation models. Spend more time for the plant design than installation. A lot of people takes time concentration on installation, constructing a big factory, mega factories, or putting a big equipment. Before that, you have to spend, as a owner, as a processor, as a lead of any process, you have to spend a lot of time designing the plant. Design the process line first, then go for a civil structurals. But I have seen most of the cases, you have a building, you have some building of 5,000 square feet or 10,000 square feet, 20,000 square feet. You try to go for a mechanization, automation, sitting in that particular building. That's what is the biggest challenge today. That's what a lot of plants are not looking very attractive, because we've done a mechanization in existing structure, some adjustments. So, but anyhow, it's an old factory, so we cannot have any option, but you have to do like that only. If you, at least when you are going for a new processing lines, first design your process line and then go for civil structurals. Go for turnkey solutions instead of bits and pieces. I have seen some of my friends used to get one machine from X, one machine from Y, one machine from Z. This will not work. So when you are going for an automation, the performance guarantees for these machines are very important, and your fabricators and you has to sit together, accept some performance guarantees, which is turnkey solution are very important. End to end, one should take a responsibility and run for you in automation mode. And most importantly, involve in the key line drawings, spend a lot of time. Before constructing your factory, you can see everything in your 3D drawings today. Your technology is so fast. So go for 3-dimensional drawings, have a look and have a feel of your plant, then go for a construction of the same. And prefer rugged machinery than very delicate machinery. See, we cannot say that Benz car and Maruti are the same cost. There's a difference in the cost. And there are a lot of customers who are buying the Maruti or who are buying the Benz. And both have a same purpose of traveling from one location to other location. But nobody is a fool around. Whether Maruti guy have a Maruti standard or Benz has a Benz standard. So let us understand these fundamentals, go for the rugged machinery, go for the rugged structures, and which can stand for you at least 10 years. Okay, and most important thing is make use of stainless steel parts as much as possible in the contact parts, and ensure a strong structurals to align technology changes every 3 years. You are saying that 4th generation, 5th generation, 7th generation machinery keep coming. So at least your fundamental structures which is handling these machines should be so strong that it should be there for next 10 years. So only that particular shelling machine can be changed, or particular peeling machine can change, particular shaft can be changed, or such that at least 50% of structural cost will be stand for at least 10 years. And ensures strong structural elements. And most important, avoid epoxy flooring. I have seen a lot of people putting epoxy floorings, and it's not going to help you. It will further damage the plant. Whenever there is a trolley movement, whenever there is any movement of a harsh particles, don't go for epoxy, and it is going to be a big head pain. And HACCP based designs are very fundamental. Linear flow is very fundamental for this kind of automation. And cross ventilation, sweating issues are very heavy in Africa particularly, and India, southern India. So go for such a design that cross ventilation is perfect, or absolutely avoid particularly heat areas from the workforce areas, such a way that means people feel comfortable. Okay. So with this, I'll conclude on automation prerequisites and concept. Thank you very much. Thank you.
Thank you very much, JC. It's always a pleasure to hear your special comments, and I think it is going to help a lot of people who are really having a vision to process. And anywhere, any part in the world, it's not only just African. These are really fundamentals coming from a person who really live in it day by day. I'm going to now invite Mr. Charlie Chen, who is going to talk about X-ray technology and its use in Cashew processing. X-ray technology, we was talking just last, a couple of, not even a couple, I think I said 2 years ago, we started thinking about how we are going to address the foreign material in the final packing stage, which are not, you cannot identify those things by having a metal detector. X-ray treatment is not just to talk about irradiation on the food safety side, it's much more on the how to separate those foreign metals at the final stage. And I was spending some time last 2 months, and I saw some nations like Vietnam, almost everyone is going for this. Most of the factories are already adopted new technologies. African countries and India also, they are coming up back. I think there's going to be a big demand, I think, for such kernels where we guarantee that our final packs have no foreign material at all. I would like to invite Mr. Charlie Chen, who is the marketing manager for Mymere, one of the big manufacturers for such type of equipment, providing solutions to the customers.
Ladies and gentlemen, good morning, everyone. It's glad to have the opportunity to stand here and appreciate so much of WCC and the professional platform here. And Cashew nuts collected us here together. So I need to say thank you to the lovely Lutz Cashew. Then we need to thank you, Vietnam, Africa, and India, because of this beautiful land, the cashew nuts planted there. So people like it, need it, enjoy it. What's that? Cashew. And people want it with better quality and better taste. So thank you all here, standing here, to contribute to the world for the cashew nuts. My daughter, at the age of 4, he ate the cashew nuts at the first time. But me, until the age of 30, I ate the first cashew nut. So year by year, day by day, the people love cashew nuts more than before, especially the place that we don't have cashew nuts, just like China. So thank you again, all of you sitting here. So let's start my presentation here. Actually, it's my 5th. I canceled the 4th before, because I don't want to talk more about the technical issues and the details of everything. I just want to share with you, and I want to discuss with you. Just like I want to thank you, Mr. Jesse just now mentioned about the color sort output, how to decrease the percentage of breakage. So I just want to have a conversation with you and want to discuss with you about this. Today, the main topic is X-ray machine. Most of you sitting here, most of you are our clients. Maybe you know color sorter, you know Mayer color sorter, but maybe you don't know much about Mayer company. So allow me to first to introduce about Mayer company. What is Mayer Optoelectronic doing? Our version is dedicated to offer high technology services and solutions integrated with intelligent identification technology. So during these two sentences, identification is our key word. All Mayer fields and products focused on this detection and identifications. Mayer employee introduction. We have doctor degree employee over 100, and research R&D engineer over 300, and total employee of 1,200. We do service and products to all of the world, not only for cashew, but for all the other agricultural fruits, even industrial field. In 2014 Forbes, we are the number 5 of top 100 Chinese companies with great potential. And in 2016, the China Chief President, Mr. Xi Jinping, has come to Mayer company because of our the R&D development on this digital and intelligent color sorter and X-ray machine and even the medical machines. So thank you very much of Xi Jinping as well. So Mayer fields exactly includes for agriculture, industry, and medical 3 fields. But we are here, we are focused on the agriculture and food field. Actually, we are famous of each fields for food: cashew nuts, sesame, rice, different kind of beans, pulses, peanuts, etc. For industry, we are doing recycling, sorting, and detecting plastic, mine stones, recycling metals. And for industry X-ray machine, we have X-ray machine for tire. So we have a partner and we have our clients just like GT, Cooper, Continental, like this. And for medical, we have the CT machines for clinic and doctors. So let's start about food, because this is our main topic. For food, we have 2 machines. We divide it as 2 parts. One is quality control. The quality control is the basic quality control that the consumers, the importers, which they are needed, just like color sorter. Why we use color sorter? Because color sorter can satisfy the request of discolored and poisoner discolored kernels or the others to be separated. And another one we call safety control. Actually, safety control is deeply quality control, just like X-ray machine. But these 2 machines have one common feature, is what? Just like long time ago, there's no machinery to sort, to separate. What do we do? What did us do? By human beings. The cashew nuts, discolored, you can see by your eyes. The good one you can see by your eyes. You have your brain, you know which one is good, which one is bad. So this is optoelectronic. When you see, the camera see. When you make the decision, the software makes the decision. And then you want to separate, it's by ejecting, by air. So this ejecting is your mouth, is your hand. X-ray machine is just not by your eyes. It's by X-ray source, can see the inside. It's by density, or it's by the difference of different kind of material absorbing the X-ray source, the quantity. Then give the reflections to the software to analyze which one is cashew nuts, which one is metal, which one is stones, which one is the ceramic, which one is the plastic. But for X-ray machine, the difficult thing is the standard. Different kind of material the X-ray machine can detect, but the standard is different. Okay, even I don't want to keep this PowerPoint. So the X-ray machine can detect different kinds of foreign materials, but the standard is different. So that's why I stand here, I want to describe and to explain to everyone here. If it is cashew nuts or it is sesame, if we run the X-ray machine without any node, without sesame or without cashew, just empty running, you put any foreign materials, metals, stones, glass, all the machines can detect all this, whatever the size it is, and can eject it. But if you mix this with the cashew nuts, comparison with the sesame, then the detecting accuracy is different, because the single sesame and single cashew nuts absorbing the X-ray source, the features are different. So comparison with the foreign material absorbing the X-ray source, so totally it is analyzed work. So for X-ray machine for cashew nuts, if you want X-ray machine, you need to know why you need X-ray machine. What kind of foreign material you want to sort. What's the size of foreign material you can control. Because also you have grader, you have the others. Maybe you can do the combination solutions for everything. Well, let's continue. So Meyer, for sorting machine, we have cashew sorting for discolored and also for size. And for scenario solutions, we have whole kernel sorting, broken kernel sorting, and shell mixed sorting. We have different kind of machines. For X-ray machine, we developed the X-ray machine for bulk material and also packed material. But for cashew nuts, I think till now the bulk type is the one popular needed and requested. These are the X-ray machines. One by one. This one is the bulk X-ray machines. From the picture, you can see the different material, the foreign material absorbing the X-ray source. Then they give you the features, give you the images are different. Then the software can analyze and can control the ejecting parts to eject the foreign materials. This is the packed X-ray machine. Maybe one day we do 10 gram, 20 gram, 50 gram to the supermarket, to the kids. What's the family or what's the people concerning? They want this safety. They want the kids eat this. Inside there's no metal, there's no stone to break the teeth, to break the body. So also we have machines can detect again after packing. You can see the package inside. There is foreign material a lot. And the X-ray main machine, beside you can see 5 pictures more. We have different kinds of executive parts to satisfy the different kind of factories' request, and different kind of packages, different kind of executive parts are suitable for each one. And also we have the cans detected X-ray machine. This is, everybody knows that milk powder is very important to be detected by the X-ray machine of this cans type. But maybe one day I imagine cashew nuts can be made to different kind of food, maybe resources, maybe whatever. It's by cans. Also, we need this X-ray machine in the future. This is the potential request for cashew deeply researched. And then this is the Meyer, another X-ray machine. It's for fish, for meat. Japan, the kids, when they're in the kid gardens, they eat the fish. The fish must be controlled without any bones inside. So the supplier needs to know how to do this before exporting the fish. They need X-ray machine to see every single fish meat. There is bones inside a lot. So this is the X-ray machine scenario for fish. But the theory all the same. The bones absorbing the X-ray source. The meat itself absorbing the X-ray source can give it different features. That's why we use this theory for different kind of X-ray machines for different kind of materials. So this is my brief presentations for X-ray machine. I hope this can be helpful for the Cashew Labs promotions in the future. Thank you very much.
Thank you, Charlie, for such a rich presentation. We are actually running out of time, but we can take only 4 questions. Panelists will be here after we finish the panel, and you can actually talk to them one by one for your queries. Let's take maximum 4 questions, 1 for each panelist. Okay, I think let's start from here.
All right, from Damodar Kamat, pardon if I didn't pronounce that correctly. What is the capital cost for a 1.5 megawatt unit, and how much cashew shell cake required to generate 1.5 megawatt of power? So on our current estimates, it should be about 1.6 million. We're obviously in implementation going to shave a bit off of that. And we expect that as more plants are built, we'll figure out where we can have additional savings. But currently it stands at about 1.6 million. And for generating 1.5 megawatts, it's roughly 8,000 tons of de-oiled cake for 1 megawatt. So we're talking about close to 12,000 metric tons.
Thank you. Another question will go to JC.
What is the good solution for flooring? Correct, no? Yeah. So there are, this is one of the very important point. So actually, if you look into that, the flooring, that's why I touched upon only epoxy means that have a peeling capabilities. And as of now, if you look into the flooring, granite is one of the best flooring we can think of. And industrial tiling is also another best flooring concept you can think of. But always use epoxy filling between the tiles. Just maintain 3 to 4 mm between the 2 tiles or any stones what you want to place. And fill within this fills, go for epoxy filling, because whenever there is one single tile damage, you can remove the tile, replace with the other tile. So I recommend these 2 no, for any industrial flooring, particularly for cashew.
Thank you very much. I think we can take 1 question for Meresk if someone want to talk, because otherwise it's going to be a big list of questions, and 1 for my mayor. People can talk. We can send the mic to them rather than going with big list. Is there any question which can you?
Hi, my question is to the mayor. See, we are speaking about a lot of machines, and as you said, an X-ray machine for the fish to see the bones and all. Is there any such machine where we can see the infestation inside the cashew, which we are all facing, everyone? Is there anything of technology such we can see that when passing through your machines?
Thank you very much for your questions. I think that we have misunderstandings of X-ray source this technology. Just now, as you request, it's just like what we know about peanuts, aflatoxin. This is the inside. The X-ray source, actually, if you know that the X-ray source absorbing, they are the same. So for X-ray technology, this cannot. But for this, also we are researching. But by commercial use, I don't know which time we can put this another machine to the market. It's called laser machine. Laser technology can know the difference, as you said, even aflatoxin like this. This maybe can help you in the future, but till now, the X-ray technology cannot. Thank you very much.
Anyone for Meresk? Okay, you already have? Okay, great.
All right, this is a question that says, can Maersk finance my cashew cargo from Africa to India, Vietnam, if I'm a trader who is based in Dubai. We well appreciate the fact that a lot of traders are in fact based out of Dubai, and a cargo of cashew moves out of Africa into India and Vietnam. And we have a dedicated trade finance office based in the Dubai International Finance, which controls and regulates the finance solutions. And I'm sure if you meet one of our experts, either Mr. Manish Mehta or Fuad, who's present in the room, and suggest your case, then this is certainly possible.
Thank you very much for the panel, and I think we will stop here because otherwise it's going to be take a lot of time. I think, thank you very much. Give them a big applause. I think they did a fantastic job.
Well, we thank Mr. Shaktipal and all our panelists for their valued opinions and detailed, informative presentation that they shared here with all of us, bringing much clarity to the mind. And at this moment, I would request our moderator, Mr. Shaktipal, to kindly present mementos to all our panelists as a token of our gratitude, starting with Ms. Kishwar Siddiqui. Thank you so much. Thank you so much, ma'am. To Mr. James Oborowski. To Mr. Jayachandra Reddy. And memento to Mr. Charlie. And I would request Mr. Jairo Gomez, Director General, DML Produce Columbia, to kindly come and join us on the dais to present a memento to our moderator, Mr. Shaktipal. And we'd like to mention here that Mr. Jairo Gomez is participating for the very first time in WCC, so a very warm welcome to you as well. And your presence here is truly valued, and we hope to see you, that is Mr. Gomez, in many more conventions. Thank you so much. And we'll quickly have a group photograph of all our panelists.